All right, Connor. Now you've had plenty of time to figure this out.
Yeah, I really have, and
You could have asked for help about 18 times by now.
I did ask for help about 18 times. You know how useless the people around me are.
Okay, limits at infinity. Limits at infinity is the same thing as horizontal asymptotes. So, weird, we started again. So horizontal asymptotes is limits as x approaches infinity. That's limits at infinity. So when it says the word at, it's telling you the x value that you're using. So infinite limits, which I 100% don't like these wordings, but that's how you'll see it. Infinite limits is when the limit answer is infinity. So the only time the answer would be infinity would generally be on an asymptote. So on asymptotes, how your graph curves up or curves down, the answer could be infinity or negative infinity. So those are infinite limits. I don't think you're going to have a direct question that asks you which one is which. But what you are going to get is you're going to be asked the limits as x approaches infinity, and then you'll also be asked this. Now, the other thing is, if your answer is infinity, sometimes it'll say infinity, semicolon, no limit, or does not exist. Because infinity is not an actual number answer. And so infinity is just kind of like an idea. So you're supposed to basically understand that your answer is going straight up without bound, but it's not an actual physical number.
I was just going to say, so what, would that just be a...
So this would be on the same letter choice.
Right.
So
I'm saying, what would be the visual representation of a limit?
A vertical asymptote.
So
it'd be like a vertical asymptote right here, and your graph goes up. That would be an infinite answer.
The limit as x approaches that number, which is the asymptote.
So it would have to say from the left or from the right.
Okay.
It wouldn't be a two-sided one, most likely.
That one would be from the left then?
Yep.
Because it's approaching the asymptote from the left.
Yep. Let's see, what else? Do you guys remember how to do the ones where the limit as x approaches infinity? Do you remember the easy way to do it? You put infinity in place of x, and you figure out the answer. Remember, yes, so you ignore everything but the highest power, and then you kind of determine infinity works like a variable almost, where you can cancel powers, things like that. Oh, okay. Oh, if you had Mr. Stouffer did anybody have Mr. Stouffer try one probably? Okay, he did it way different, so ignore what I said. He did it the way the textbook shows, where you write it as 1 over, I believe, divided by a variable, so it said 1 over x instead. Okay, never mind. Let's go to Unit 2. Unit 1 only took us, what, a half hour? Mm-hmm. No, 45 minutes. Okay. Yeah, we'll blame it on the Wi-Fi. That's all right. Well, like I said, you guys remember the newer things, so it's not as big a deal. What are you doing, Josh? What are you doing? You got Geometry Dash at Aldi, I guess.
It's math related.
I see. Okay. Limit definition derivative. Oh, I can't even use the number generator. Dana, I haven't called on you for quite a while. This is going to be a tough one. Do you remember the limit definition of a derivative? Okay, because you guys are going to have to. You do?
Isn't it like the limit as x approaches h or something of x plus h minus f of x already?
I think, hold on, I'll write it. I think you said it possibly correct. So you can have an h or a delta x. Both ways are pretty common. It's f of, I think you said f of x plus h minus f of x. I couldn't remember what you said on the bottom.
Just say yes.
Yep. Then that was correct. So this is the limit definition of a derivative. You sometimes are going to be asked, like they will put equations in place of f of x and f of x plus h, and then they're going to ask you, what does this represent? So you're going to want to look that up if you don't remember them. Differentiability and continuity connected. Basically, it can only be differentiable if it's continuous. So if you're asked to find the derivative at x equals 2, but it's not continuous at x equals 2, then that means it's not differentiable there and it would have no derivative or no slope. So the only way you can have a slope, differentiability means derivative, the only way you can have a derivative at a location is if it's continuous at that location. And you might get questions associated with that. Power rule, I hope you remember power rule. We've used it a lot. But some of you might have it backwards because you're so used to doing the integral power rule lately. So power rule means if you have x to the n and you're taking the derivative would be n times x to the n minus 1. So you multiply the front by the power, subtract 1 from the power.
That will be, like, in my mind, it always goes up now.
It is a little bit harder to remember. Product rule, I'd be impressed if you guys remember product rule. Derivative of f times g. So if you have two different functions and you're taking the derivative, it's going to be fg prime plus gf prime. It basically means take one equation times the derivative of the other, plus the other times the derivative of the first. So one of each. Quotient rule is similar, except it's annoying because it is backwards. So f over g is going to be gf prime minus fg prime over g squared. If you guys remember the little song that went with that. Low d high minus high d low over low low.
I like that girlfriend prime. It's like a robot girlfriend. What goes through your mind? Girlfriend prime.
Okay, so if it helps you remember the correct order,
Yeah.
go for it. Yep, that's all that
What's
matters.
it called? Girlfriend prime.
So I shouldn't have said song, it's a limerick. So the limerick that goes with the quotient rule is low d high minus high d low over low low. High is f, the top. Low is g, the bottom. High and low. So low d high minus high d low over low low. It's kind of like a Seven Dwarves song. That's what it feels like to me. And some people just like songs and lyrics and it's going to be hard.
You're all going to remember it.
Unfortunately, I'm going to remember Girlfriend Prime, yes. I will not be using that phrase to introduce it next year, though. Trig derivatives. I already know you're going to have issues on these. So triage. Triage is kind of like the concept of do what you can, right? Like when you're in war, you want to save their life, not save their leg. Something like that, you know? So it's like you kind of pick the big things, the important things. If you are in the boat, that you're not going to remember all 6 trig derivatives. And I know some of you will be able to, okay? But some of you probably feel overloaded with information by now. At least remember sine, cosine, and tangent, because they're by far the most common ones. So if you're going to pick and choose, pick the most common ones, sine, cosine, tangent.
I just wanted to let you know, Benjamin Davis at the dentist appointment this morning. His dad called in, but he's joining the meeting now.
The meeting's not on.
Did you tell him that Iron had died?
Oh, no, is it still dead?
I don't know. Yep. Still dead. Usually when it goes down, it stays on for a while, so. Okay. What are we at now? 9:20. Okay, so like I said, if you guys are feeling overloaded, pick the big things, the main things, because those are far more common. You know, if it's going to help you get 3 questions correct instead of 5 questions correct, go for it. Are you FaceTiming for him?
It's Benjamin Sayers.
Hi, Ben.
Um,
How are those pearly whites?
oh my God, you guys.
They do look pretty. What are the three derivatives?
Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. What? You can. Oh, okay, go for it.
Are you cooking breakfast?
Connor, you are having issues today. Yeah, that's fine. FaceTime, but he doesn't want to watch you. He wants to watch the board.
He is watching.
Okay, good.
I just saw his pain.
On multiple choice, you probably know this by now, but never leave them blank. You guys aren't going to be able to go out of order, which I don't like, but hey, that's kind of what you're going to have to do. So remember, you're not going to be able to go back to questions. If you get to a question that you have no idea how to answer it, guessing is perfectly acceptable. If you have an educated guess, go for that. Like if you know it's between 2 of them, that's a good educated guess. Otherwise, the best strategy is always to pick the same letter. I would not pick C because that's what everybody always says to pick, and usually AP is like trying to reverse psychology or something. I don't know. So I would go with B. I'd go with A or B. But if you're just flat out guessing, do the same letter every time. Don't just randomly pick. For whatever reason, it's definitely been proven that you end up getting more points by choosing the same letter than random picking, even though the probability is the exact same. So just pick the same letter if you are completely guessing. Let's do Unit 3. Maybe we'll stop after derivatives because I think integration you should be somewhat familiar. Chain rule. A few people asked me about chain rule yesterday. Chain rule is... say it again? 2u times du.
X prime of u derivative of x squared.
Got you. So that's on the power rule. Yes. So the way that they show it with notation is that the derivative of f of g of x, actually let me erase this parentheses on the outside so it's not overwhelming. The derivative of f of g of x is going to be f prime of g of x times g prime of x. G prime of x is du, like what you were referring to. So this form works for power rule, quotient rule, product rule, trig derivatives. I guess that's pretty much all there is. So yes, if you have a bunch of things squared, this is what u substitution is for chain rule. So if you have a bunch of things squared, that's what we use u instead for. And then your derivative would be 2u. So f prime g of x, so u is still a u. That's why g of x stayed the same. But we did the derivative of the squared. And then we would multiply by du, which is g prime. Most of you don't like this notation, right? Like most of you probably can't stand that notation. But you're pretty good at just knowing u substitution. And if that's the case, that's good. U substitution is chain rule. Like, that's what it is. Now, the downside is this correct notation that I circled. They often are going to have, like, property questions for you, where they might tell you, they might give you a table that says f of 2, f prime of 2, g of 2, g prime of 2, and then they'll ask you to find the derivative of f of g of 2. And you're going to have to use the chain rule to do that with this notation. So it's not bad to know this. Oh, we might have gotten internet back. We did. I'll put Zoom back on.
Bye, Ben.
Okay, there we go. Implicit derivatives. Who should we go with? We should go with... Who haven't I called on yet? Milan? I haven't called on Milan. Do you remember what implicit derivatives are?
Is that like the dy dx thing?
Good, very good. Do you remember like when we used it? But you're correct.
No, I don't.
So implicit is when your equation isn't solved for a single variable. Explicit is when it says y equals or something like that. So an implicit derivative is generally used when it's not a function. Like x squared plus y squared equals 10. We would do implicit derivatives and just do derivatives on each individual term. And yet we use the notation dy dx for that. Derivative of an inverse. I don't even know if you're going to have a question on this, but I just put it on there because that's what AP has as part of their main things to know. I've only seen a question on derivative of an inverse like every 4 years. So I don't know if you're going to have it or not. This is a formula to remember. If you want to learn the formula again, go for it. If you're doing triage, which I know I don't really like using that term, but I also know some of you are on the boat where it's just you're trying to do lots of things. This is probably something to skip. If you're the person that's trying to like just get all the big things in. Derivative of an inverse, it might be one question. Higher order derivatives is the same. Get out of the way. Higher order derivatives is second derivative, third derivative, fourth derivative. That's what higher order derivatives are. They can be done on explicit, so this would be the notation for higher order derivatives of explicit. If it's implicit, then you would have dx squared over d squared y. Yeah, that's correct. Wait, I have that backwards. I wrote it upside down. So whatever the number is on this, wait. Why can't I erase now? Trying to think of too many things in my head at one time. We do ddx, so the numbers would go on ddx of y.
Excuse this interruption.
Internet now works.
The internet should be back up and working, so sorry about that, and you should be good for the rest of the day.
Oh, he should not have said that. He should not have said that. Oh, no. Oh, no. Yep, go for it.
What's the formula you were talking about for the inverse? Derivatives of the inverse.
I'm going to do my best to try to... Yeah, I'm going to do my best to try to remember what it was. F prime inverse. No, F inverse prime. This is why nobody likes the formula. Yes, we did. Yep. In F inverse prime of, I believe we used A or C. Because you only do this at an individual number. You don't generally do it for an equation. F inverse prime of C is 1 over F prime of F inverse of C?
Holy cow.
R.
Pretty sure.
You remember that? Sure.
But look it up.
What?
Yeah, that should be.
Was that right?
Easier?
Well, it's just a simple.
If you remember the formula, it's not bad to do. The formula is the hard part to remember. I usually do it a different way, and I taught you guys both ways. I usually just do a method rather than a formula because I'm bad at remembering formulas. Let's do the last. Actually, I don't think that's the last derivative one either. Nope. Okay. We'll get what we can done, and I'll stop a little bit early. I don't want to go right till 9:50 because I know you guys don't want to. Identify derivative wording in problems. Do you guys remember the one key word that means derivatives? Rate. Excellent job. You should have started with that, Joe. You should have started with that.
Where was that at?
The rate is the most common thing. Otherwise, the only other wording that you might see would be like wording like 5 miles per hour, you know? So this wording is for a rate, even though it might not use the word rate. But if you see something that says per, that is a derivative already. Oh my goodness. Related rates are the word problems that involve things like this. So you're going to do implicit differentiation on word problems. It's usually something like the Pythagorean theorem or some sort of a triangle formula or something like that. We've done a circle, a sphere. They'll give you the formula on the test unless it's super obvious like a circle or a rectangle or triangle. Local linear approximation was a method for estimating a location on a line if you don't have values. So you use the slope and an x value to do it. I don't remember the formula off the top of my head. I feel like it's something like L of A is F of A. Like this is an educated guess here right now. It's like F of A plus F prime of A times. So it's the original value plus the slope times the change, like x minus a or something like that. If you look up the Khan Academy video, it's just very straightforward. Was I right? I can't read that. F of x0. Yeah. Nice. Let's pretend your teacher knew what he was doing. Nailed it. We did L'Hopital's rule. I doubt you guys have been adding up these percentages along the way, but it's basically half of the test is derivatives.
Oh, that's fantastic.
I think integrals is like 40%, and then limits is like 10%.
So basically, limit, derivatives, integral.
Yeah, that was pretty much our class too, though. So yeah. I mean, units 2, 3, 4, and 5 were derivatives. 6, 7, 8 were integrals. 1 was limits. So, mean value theorem for derivatives is not the same thing as average value. So it's easy to get those confused. Mean value theorem of derivatives means that the instantaneous slope is going to be equal to the average slope at some point between A and B. And they would write this formula on there for you. You generally don't have to remember this formula. But it's where the instant slope equals the average slope. That's what mean value theorem was. First and second derivative test. First derivative test is about relative maxima, like relative max and min. And you look at increasing and decreasing. Second derivative test is for concavity. And so at curvature, it finds inflection points. The other thing from first derivative test was critical numbers. So that's when the derivative is equal to 0 or undefined. I mean, like, this is obviously me condensing this a lot, but that took a long time to cover. Curve sketching with slope and concavity. I infrequently have ever seen this on the AP test, even though it's listed as a topic you're supposed to know. You're not going to have to sketch a curve on your own. Most likely what they would do is show a graph and then say, where is the inflection point? Where is the relative min? Things like that. So it's pretty much just basically you have to know what these things look like. Especially because this is all computer test. They're not going to have you use your mouse to draw a graph or something. They would just have you choose things. Optimization is where you maximize or minimize a word problem. And if you remember optimization, you have a primary equation and a secondary equation. Your secondary equation is only used to substitute information into the primary. And then you're going to take the derivative of the primary equation and look for critical numbers for maxes and mins. I know that's condensed a lot. Those are not quick problems. I don't know. I'm actually impressed how much information we just covered here. I wasn't expecting to go over all 8 units. I thought you guys would need the most help on limits and derivatives, so I just wanted to quickly cover a lot of that. If you're not taking the test, obviously you just didn't care what we were doing, and maybe played Geometry Dash. Nice. Hey, that game is tough. I know. I've played it. It's really tough.
Imagine if like every time you jumped, the screen just like paused and you had to like find the derivative.
We should make Calculus Dash. Okay, computer programming class. This is what you guys can do. Make money off it.
Sounds like one of those things like cool math.
Yeah. Yeah. But every calculus class would like pay for this and use it for review.
Yeah, that's what I'm saying.
You would make money because educational teachers need resources, and that would be an easy one.
That's just like
It's dumb, but it's okay. It makes money.
it's like the CEO of like 360. It's just evil. Like he's like making bank. There are like some people who are just plainly evil in this world.
So if you had a choice between just regular reviewing and reviewing is the Calculus Dash.
Yeah, it's a game.
I mean, like, you got to review anyway.
Look, I can review for an AP test in an hour and a half and get it fine. It's wow. For someone who's not taking the AP test. It's one of my special abilities.
Ben, how did you do on the economics?
I see that. Wait.
Economics is different.
Let's.
But they have to study for that test.
Oh, I got to chat. Sorry.
See, I should start not studying.
Could I possibly post the slideshow thing? I'm slow. Yeah. I've been recording, Ben. So I recorded on Zoom until the internet died, and then I'm recording what I got up here now. So I'll post both recordings, I guess. But yes, I definitely will post it because I know not everybody can see this.